let's imagine a problem where you will be given an integer. Let's say you have an integer and you are basically counting it. If your k is 1, like if your k is 2, you need to do this iteration 2 times basically. So let's say if it's 1, you start with 1. You say 1 1, right?
Sorry, could you
In the
repeat
first
that
equation,
that question? Sorry,
oh,
I'm a bit.
oh,
I got
oh, you will
confused.
be given an integer target like k to do a particular step k times. Target k to do it k times.
Yeah.
Each step involves counting the digits you have. You start from 1.
Okay.
We start from 1. If k is 3, you do this step 3 times, basically. 1, right? Next, how do you count it? 1, 1, right? Then in the next step, you write 1, 1. And these are like 2 ones. No, it's in the next step, in the third step, it would be 2 ones.
What's this?
2
Oh.
comma 2 and 1.
Wait, sorry. So you're given a target k.
Yeah, let me just type it. In the first step, it would be 1, 1. If you count it, it will be 1, 1. And in the next step, it will be 2 ones. So I just pasted a small output if k is 3.
So we're given 1 1. The next step is going to be 1 1. Given a target k, do it 2 1.
Yeah, because it's 2 ones, right? How do you count the seventh line? 1, 1. It is counted as 2 ones. Okay, let me.
I'm still
Okay,
confused a bit on the explanation there.
yeah. Okay, let me give you the question problem statement as well.
Okay, is this will they just give it to us the whole problem statement or no?
No.
They'll explain it the way you were explaining it, kind of.
Yeah, but in a better English, I guess.
So okay, let's see.
They won't give you this entire problem statement normally, because I was struggling to come up with words. I just gave you this, but yeah.
Okay,
So okay, yeah.
so we're given 1, and n is the run length decoding of n minus. So run length decoding is a string compression method that works by replacing consecutive identical characters repeated with the concatenation of the character and the number marking the number of characters.
Okay,
Okay.
let me paste this. Let me give you an example for a clear idea. I have an example as well. I gave you an example.
Yeah. Okay. Down there.
Yep. No. Yeah. I gave an example in the chat. Yeah. Yep.
So we're given 4, right?
Okay. You can restart the time because it took us a lot of time. We can restart the timer and do it again. Yeah.
Okay.
Now we
Sounds
can
good.
start. Yep.
So we're given a pretty much example. We're given n equals to 4. So we start with 1. Then we say
Mhm.
there's 1 ones.
Mhm.
Then we say there's 2 ones.
Mhm.
Wait. One. Let. Okay, and then the run length of coding of 2 1 is 1 2 1 1.
Okay.
Okay, I see.
Let
I
me
see.
explain it. Oh, did you
Oh wait.
understand it? Or
I see. I see.
hmm. Yeah. How do you basically spell the first line? It's 1 1. So you counted and spelled. You wrote it as 1 1. How do you spell the second line? There are 2 ones, right? 2 ones. So you wrote 2 1. And next you said 1 2 and 1 1, right? How do you spell that? If they are of the same, you just say basically increment the say basically 3 times. I saw 3 threes, and in the fifth step it will be 1 1
Okay, I
1
see.
2 2 1.
I see. I see.
You can write the fifth step to make it more clearer.
Pardon?
One.
Yeah. Let me
Oh,
write the fifth step.
yeah.
So we're given 5. What's 1 2 1 1? So essentially, what's the run length decoding of 1 2 1 1? We'll say there's 1 1.
Mhm.
There's 2 ones. and there's just
So,
two, or sorry, there's 1 2, sorry, 1 1,
mhm,
and then there's 1 2, and then there's
mhm.
2 1s,
Yep.
right?
Yeah. Yes, that's the problem. Yeah.
So let's see. Given a positive integer n, return the nth element of the count in say sequence. So the initial approach that I'm thinking is we could just simulate it all the way up until the n, and then return it.
Mm-hmm.
Um, there might be a more optimal way to do it because that's going to take a while to
Mm-hmm.
run. I'm trying to figure out the time complexity of that, but essentially it's going to be like at least O of n times
Mm.
n again, essentially, or n my. It's gonna be it's gonna be a summation because we're gonna do it n times, but the first one's only gonna be 1, then the next one is gonna be 2, and the next one is gonna be 3. So
Mm-hmm.
it's gonna be like an n squared algorithm, right?
N
So
squared.
or n times like a summation of is that a x n by n algorithm? Let's see. Honestly, I'm not too
Oh,
sure of the time complexity if we
yeah, yeah, we can skip this part, implement it, and then come back time complexity if you would like.
okay.
But we can discuss the approach and we can figure out the time complexity later.
Okay. Yeah, so my
That
approach is
sounds
pretty much, well, we can write a function that could
good.
generate
Mm-hmm.
because there's two approaches. I'm wondering if there's a faster way to get to it.
Mm-hmm.
Like if there's a pattern here where we could just skip, but if we were to just brute force it, which is start at 1, then take 1 and then do 2, then take 2 and then do 3, then take 3 and
Mm-hmm.
do 4 and go all the way down. We would have to we can like recursively call the function
Mm-hmm.
until we get to the specific depth, which is 5. And at
Mm-hmm.
each time, what we can do is we can write a function that kind of takes a string like this, and
Mm-hmm.
it moves from left to right. Maybe
Mm-hmm.
we have 2 pointers, and it figures out it moves the right pointer until it's something different, and then
Mm-hmm.
it counts the length there, so it's gonna be 1. And then we do like a string, like we count the length, and then we also count the number here. So we say the length is 1, and the character is 1. So we push like 1 1 into some string builder, and then we move to
Okay.
2, and then we move this,
Mm-hmm.
and then we see um, or sorry, it's like a sliding window. We move this, and now we have a single digit. So we're gonna move this up, and now we pretty much let it grow to get. Uh, we pretty much trying to find the sequences of just straight, of like contiguous sequences of one exact digit. So we
Okay.
see that breaks, and that's a length of 1. What is the element? It's like we have like 1 2, and then
Mm-hmm.
we move this up, and then we keep moving this, and then now we get to the end, and now we have basically the length is 2, so we have 2 1s, and then finally we join that, so we get 1 1 1 2 2 1.
Mm. Yeah.
So like a sliding window approach. And we pretty much do that recursively. So 1
Mm-hmm.
1 will generate 1 1, and it'll pass it down to generate the other
Mm.
one, and we could just calculate the depth, and we stop at depth 5, and we would just return.
Yep. Sounds good.
How's that sound? Should I implement that, or is it the time complexity
Yeah.
is going to be too bad?
No, it looks good to me.
Okay, cool. So let me
We
just
can, yeah, but we can kind of improve a little bit once when we're implementing. But yeah, recursively calling it sounds good.
okay, cool. Let's say count and say
Mm-hmm.
we're given this function count and say, and we're gonna be given a string, or we're gonna be like sequence,
Mm-hmm.
right? And then for the sequence, what we're going to do is we're going to also have our depth, the current depth, and then we're going to be the current depth is equal to 0, but then we're going to have our target target depth. Then just rearrange these. Right, this is our target depth. And then what we're going to do is if the depth is equal to the target depth, we just return the sequence. So that's when we get to the depth that we want, and we'll call this with like count and say 1. So essentially what we're going to do now is we're going to do our two-pointer solution, and we're going to be like result equals. So we have 0. We have our sliding window, and then we're eventually going to do return count and say. We're going to recursively call this sequence, but we're going to join the result. And we're gonna pass in the same target depth, but we're gonna pass depth plus 1, and we're gonna say while right is less than the length of the sequence. What we're gonna do is what we're gonna track is we want to pretty much we want to do our sliding window. So what we're gonna do is we can just keep track of let's see, we can store current value. So this is because we're gonna try to I'm gonna try to see how we could simplify this. Maybe we could just use a stack based approach where we just like put 1. Yeah, maybe we can just use a stack based approach where we just like, if it's probably simpler, but if you move here, we put 1 and we say that has a length of 1. We see 2, we see 1 again. We say this is the character, or yeah, we just if it's the same as what's already in the stack, we just increment it like this. If it's, and then when we get to 2, if it's different, we push to 1 here. Yeah, we can use a stack. It'll be a lot simpler.
Yep.
So let's just use stack here, and then we'll just say for lm in sequence if the length of stack is equal to 0, we pretty much do stack dot append, and what we're going to do is we're going to append a tuple, or let's just append a list. Wait, let me see. Yeah, let's just append a list. What we're going to do with the list is, just so we can increment it, we're going to say there's 1 of the specific element if the length of stack equals 0, or the last element in the stack, and we'll say the 0th value, or we're storing at the 1 index, which is the element, is if it's not equal to the current element. Else we do stack -1, and we say the -1, the last element is equal to stack. We'll just recreate it. Stack -1 0 plus 1, and we'll do stack -1. So that will get us stack -1. This will increment it, and then we keep that same element there. We could probably just do this. Yeah, and then once we have the stack there, Well, we just need to generate the string. So to do that, we could turn this into a tuple. To do that, we can do. Let me see. Create as strings. Are you still here?
Yeah.
Okay.
Oh, I'm talking. Yep.
Oh, sorry. For just sorry. My bad. Assert as strings dot append. We say lm dot or join.
Mm-hmm.
Sorry. So we join all the different elements in our stack because they're going to be tuples, and then finally we pass this in.
Mm-hmm.
And then pretend we're at target 0. The target depth is 1. And the sequence is. So pretend the sequence is 1. So what we're gonna. Oh, when they say count and say, it always starts as 1, huh?
Yep. It always starts with 1.
Okay, so we're gonna have to create a function that kind of wraps this. So we can call this like recurse. Then we could say like count and say passes in like an n. Then we say return recurse of, we start with 1 and pretty much the target depth is 1 and we start with a depth of 0. Oh, sorry, the target depth is 1 here. So for target depth we start at 0, so we take 1 and we should convert 1 into 1 1, and then we should increment the depth. Now depth is equal to 1. It will just return the sequence there, and it will return the sequence against here, and then eventually return it at the end. How does that sound? Should I do a dry run? Does the code here make sense? Or?
Yeah, the code makes sense. Yep. Yeah, can we just pass in one in the function itself, in the recurse function itself?
Pass in 1 here?
Oh, yeah, this is fine. This is fine. Yeah, this is fine. I was thinking of passing one in the instead of wrapping it around, but yeah, this looks good. Yeah, we can try run it.
Okay, cool.
The code makes sense. Yeah.
Nice. And how do we feel about time and space time complexity with this algorithm?
Okay, what do you think the time complexity would be with this?
Pretty much, we're gonna iterate n times, right?
Mm-hmm.
But it's gonna be multiplied by a summation of, for the first one, it's gonna run 1 time. The next one it's gonna go 2 times. The next one is gonna go 3 times. The next one is gonna go 4
Mm-hmm.
Right?
Okay, the first one is gonna go 1 time. Next one's gonna go 2 times. The after one that's gonna go 4 times.
Kind of.
The next one's gonna go 8 times, no?
Oh yeah, it's growing exponentially once. Well, the first one's gonna go 1 time. Then two here just goes to 2 again, but it starts growing faster. 2 goes to 4, and 4 goes to 8. So it's yeah, probably n times 2 to the n times 2.
Okay,
wait.
What do you?
Or sorry, it's probably just gonna be 2 to the n. Because that's the biggest term. Or let's see. Yeah.
Yeah, sounds good.
I'm kind of bad with the exponential ones.
Yeah, it's fine. Yeah, it's good. I think it's 2 power n as well. Yeah.
Okay.
And about the space, yeah.
About
fine.
the space, 2 to the n as well, because it's gonna grow exponentially.
Yeah. Yep. Makes sense.
How's that run?
Yeah, that sounds good. Can you hear? You can hear me, right?
Yeah, I can hear you.
Yeah, that sounds good. The time and space looks good to me. Yeah,
Okay.
makes sense.
Should we do a quick dry run on one?
Yeah, yeah. A super quick dry run on
Just to
one should
practice,
be
yeah.
fine.
Is that a is this a meta question or no? I've never seen it.
Oh, it's a meta tagged
Oh,
question.
really?
It's called count and say, and normally they won't give you this text, right? The question itself.
Oh shit, this is a good question.
Yeah.
What's
Normally they won't give you the question itself. They will just say you are counting like this. If n is 1, n is 2, something like that. They won't give you the question because the question is a lot confusing. It's fine. The approach we did is the best one
Oh, really? Okay.
out there.
It's kind of
Not the best one. It's super standard one. No one's gonna expect more than that.
okay. Nice. Yeah, that's a good question. Okay, let's count it. So 1, 2, 1. Let's say let's just do it at one, or let's just do a simple one of count and say two,
Oop. Yeah.
right? And then count and say two should give us 1, 1. Well, let's do count and say three.
Mm-hmm.
Count and say three should give us two to the two, or I'll leave 2, 1, right? So we start with one. We do count and say. We pass in n, which is equal to 3,
Mm-hmm.
and we start with 1. So we move from right to left, and we have a stack equals here. We're gonna recursive. We're pretty much gonna. I don't even know if we need to recursively do that. We could just we could just loop.
Yep.
Yeah, we could just loop. So let's just do let's do start for our range n. What we're gonna do is we're gonna say the sequence is this. So we're gonna loop through each sequence, and then we'll say sequence equal to. Let me remove this. Sequence equals to this. So so pretty much we start with 1. So that will save us some space, and then we return the sequence.
Yeah.
So
Yep.
on our first iteration, we're gonna do this 3 times, but on the first one we start with 1, and for 1, pretty much if the stack is equal to 0, stack is equal to 0, so we pretty much throw 1, 1 in there, 1, 1 stack that append one element 1, 1, right?
Yep.
And then that's the end of it. So now we just for element in the stack we append it, and we get something like this. We get a array of these, right? And then sequence equals that, and then so our sequence eventually becomes 1, 1, and maybe we'll just do it for 2, just to make it simple. Now the sequence is equal to 1, 1, and now we empty out the stack again, so the stack is empty. And then we say for element in the sequence, which is 1, 1, this is empty, so we go 1, 1. Else, or if the stack minus 1 is first element is not equal to 1, or is not equal to 1, so we move here. So we say, so this is if it's the same, so we say stack minus 1 equals stack minus 1, 0, so we keep this the same. Or no, now we increment this. Now this is 2, but we keep the same element. And then afterwards we join this and we get 2, 1. And then we eventually replace the sequence 2, 1 there. So I think that would work.
Yeah. Will it work? Okay. The
Well,
stack's tracking the last one. No.
the stack? Let's see.
Yeah, because we are at the rightmost end when we are counting. I think this would work, but you are almost right. Might have some issues maybe. So let's revisit the code again, right? Let's say we have two. What would the first step be? Our it goes in, stack is empty, length of stack is 0, so we append 1 comma 1 for the first iteration,
Yeah.
and we go down, and again there is a loop for the stack itself. We are looping over the stack. The stack has 1 1, right? We are joining it,
Yeah.
and we are marking it as our sequence, so our sequence becomes 1 1.
Mm-hmm.
We come back again, and we say for element there is nothing in our stack, so we push 1 1 in there, right?
Yeah.
And next we saw another one. Yeah, this would work.
I think
Yeah.
all I need to do here real quick is do you say f l you do lm at the zeroth, lm at the one, something like that. The, output 1 1.
Okay, can you scroll down? I think, yeah.
Nice. I, I was off by one. One means you don't do anything.
Yep.
Yeah. Cool. How's that?
Oh, this was good. Good. Very nice.
Nice.
Because this tends to be a medium to a hard range.
Oh,
No. Uh, a little towards hard, but not an average medium. Kind of hard.
nice.
Because we need to figure out the problem, and your backtracking skills are super good. So I won't worry about anything backtracking related or recursion related.
Okay, cool.
So, and the time complexity part,
Yeah, that was bad.
yeah, that was okay because people tend to confuse with exponential time. If I didn't see it, I would have been lost as well. I would have said n power n or something like that, n squared. But you figured it out, it's 2 power n after a small hint. But yeah,
Mm-hmm.
other than that, everything else is good.
Nice. Any feedback
So yeah,
on the?
oh, any feedback? I would say, how much time did we take for this?
I think about 25 minutes.
Yeah.
Kind of slow.
So, yeah, kind of slow, but it's okay. We did very good on this. But the interviewer won't be this. Sometimes most interviewers would be considerate, would let you know if you pass 20-minute mark,
Mm-hmm.
right? If some won't let, some would just start discussing with you,
I see. I
and
see.
and you would cross maybe 30 minutes, 35 minutes, or something like that, just discussing. Try to say them like, let's go to the next question and come back to this.
Okay.
If you are stuck somewhere, don't spend a lot of time on it.
I see.
Normally interviewers would say after 20 minutes, yeah, we can come back to this later. I have seen this happen, and I something similar happened to me. I told them, is this my second question? So she said no. I moved to the next one, solved it, came back again.
I see. I see.
So
Okay.
I noticed a slight tendency, like you get super interested and maybe involve in a chat or discussion and miss time.
Sorry. Could
Do you
you?
feel that? Oh, do you feel that's valid? No, no. Sometimes the question feels super interesting and we like to discuss with the interviewer a lot,
Yeah.
right?
Yeah.
And that can keep on going, and ultimately it would result in us not getting enough time to solve the second one.
I see. I
But other
okay.
than this, the coding part you don't need to worry, and the clarify part you don't need to worry. You wrote an example as well, but I would say ask a little more questions in the clarifying end. Clarify and dry run are the two most important things you can do.
Awesome. Okay. Cool.